So first of all, we'll try to get the differentiate of the function, which is that, and clearly you can see that if you differentiate on the matrix itself and then you do the trace, it's the same if you do the trace and then you do the differentiate of it. Now we just use the product. I think that's the name. If you do, you have a two function. If you want to differentiate, you differentiate the first one plus the differentiate the second one. So basically, you differentiate the first one, and then times what's left over, and then the rest part you can basically do sort of like an induction. You can do like the rest part, and then it will be like a times d a k minus 1, and then the leftover part right here, you can just open it up and do the same thing again. So eventually you would just get k times of dA times a to the k minus 1, because for each term you can first separate them, because it's a plus sign. You can separate them into different trays, and then you can do the cycler rule. So basically each of the dA you can keep moving it back, and then move to the beginning. So eventually every term can be like expressed like this. And then you can just simply times the k, the constant inside, it won't change, and then you can also put the dA to the back. So this will be the trace, and then this is exactly what the inner product defined on matrix is. Notice we need to use transpose in this case. So this term will be our gradient, which is this term.